and a very good afternoon to all of you. So in this video we will solve a problem which name is K inverse pairs array. It code 629 problem. So let's read the problem statement. So problem is saying that for an integer array nums, an inverse pair is a pair of integers I comma j. So this is the condition for this inverse pair. I should be less than j, but nums of I is greater than nums of j. Okay, so given two integers n and k, return the number of different arrays consist of numbers from 1 to n such that there are exactly k inverse pairs. So we have given a number and a k. So we have to find the number of k inverse pairs. Like let's take an example. Finally, we have to do the mod because answer can be too large, so we have to do the mod. So if n equals to 3 and k equals to 0, so we have to find the k equals to 0, 0 inverse pair. So it can be like 1 2 3 because n is going from 1 to n, so our array will be 1 2 3. So if up AR is an inverse pair, the condition is I less than j, but nums of I should be greater than nums of j. So if k equals to 0, it means that we have to find the pairs in inverse pairs. K equals to 0 inverse pairs. So there should be no inverse pair. So our array will be like 1 2 3 directly because which consists of as you can see 1 2 3 and exactly 0 inverse pair. In this if the array will be 2 1 3, then there will be one inverse pair. So let's directly do the approach for this. Let's see this. If n equals to 4 and k equals to 2, it means n is going from 1 to n, but k equals to 2, it means we have to find the inverse pair, two inverse pairs in an array. So let's write the array will be like 1 2 3 4. If I start from 1, then if I start with 1, so let's see this for understanding purpose. If n equals to 4, then our array will be like 1 2 3 4. So if I start from 1, so 1 can't make a pair because 1 can't make a inverse pair because I less than j, it is applicable, but nums of I should be greater than nums of j. But 1 is the minimum element, so it can't make any pair with another element, so it will make a zero pair. If I start from 2, then definitely 2 comma 1 will be the pair because if I start from 2, 2 is the second means we can say second minimum element. So 1 is the first minimum element is 1 and 2 is the second minimum element. So 2 can comma 1 can make a pair. It's like that if I start from 3, then 3 comma 1 and 3 comma 2 can make a pair, inverse pair. I am talking about inverse pair. So there can be two inverse pairs, but if I start from 4, so it can make a pair with 4 comma 1, then 4 comma 2, then 4 comma 3 because 4 is the largest element of the array, so it can make a pair, three inverse pairs. So let's see this example. If I start from 1, then 1 can't make a pair with anyone, so 4 comma 3 can make a pair if the array will be like 1 comma 4 comma 3 comma 2 because we have to find the k equals to 2 inverse pairs in an array. So 4 comma 3 can make a pair and 4 comma 2 can make a pair, and same as 4 here 4 comma 2 can make a pair and 4 comma 3 can make a pair. So if I start from 2, then I said in previous that 2 comma 1 can definitely can make a pair because 2 comma 2 is the second minimum element, so 2 comma 1 will be the definitely a inverse pair. So 2 comma 1 is the inverse pair, but now I will find the second inverse pair. So here k equals to 2, so 4 comma 3 and also make a pair, and same as here 2 comma 1 can make a pair and 3 comma 1 make a pair. So if 2 is in front, then 2 comma 1 will be the definitely a inverse pair. If I start from 3, then definitely 3 comma 1 and 3 comma 2 can make a pair, and we have to find the two inverse pairs, so our inverse pairs will be 3 comma 1 and 3 comma 2, so no need to check another elements. If I start from 4, then definitely it will make a 3 inverse pair, 4 comma 1 4 comma 2 4 comma 3, but we have to find the k equals to 2 inverse pair, so it will not be beneficial for us. So our array will be like our combinations will be like 1 2 3 4, and 5. 5 will be our answer. So let's see the approach for this, how we will solve this problem. This is the approach, this is a strategy that I will be using this. But the main approach is I am starting here. You can see if I start from 1, then the remaining elements are n minus 1. Three elements are there, so n minus 1 element. I am starting from k equals to 0. But you can see if I start from 2, then 2 comma 1 can definitely make a pair. So this will be k minus 1 because one pair is there. So I will see another k minus 1 element, k minus 1 pairs. If I start from 3, then 3 comma 1 and 3 comma 2 can make a pair. So I will see about k minus 2 pairs. So it will be like n minus 1 comma k, function of n minus 1 comma k minus 1, then function of n minus 1 comma k minus 2. It will be like this. So let's do the code for this. But in this problem, if you use recursion, then memorization, it will give you TLE. So you have to use the bottom up approach for this. If you if you are doing this by using the memorization approach, you will be get TLE. So let's do the code with the bottom up approach. Yeah. So in bottom up approach, what we will do is we have to make a DP. So size is 1000 and 1000. So let's create a DP of size 1001 and initializing with 1. Okay. So in this, I will be using the loop for int I equals to 0 to I less than I equals to 1 to I less than equals to n, then I plus plus. So this is for the n. N is going from 1 to n. So this is for n. Now I will use second loop which will go from 0 to I less than k, j equals to 0 to j less than equals to k, then j plus plus. So this is the second loop which is going from 0 to k. That is showing about pairs. Now a third loop that will go from int I equals to 0 to I less than, sorry, I x equals to 0 to x less than minimum of this j comma I minus 1. Why I am using minimum? Because if k will go less than 0, then it will be not beneficial. So k can go from 0 to k, be k minus k equals to 0, it will be our last. So minimum of j comma I minus 1, then x plus plus. So these three are my rules. So if I will check if j minus x is greater than equals to 0, then what I will do, I will add dp of I of j equals to dp of I plus I of j plus this function k inverse array. Let's copy this. No function is there, so let's directly do with the dp of I minus 1 of j minus x. Why I'm writing like this, gp of I minus 1, it is showing like x is showing from x is showing the k. So it will be like k minus, I have done this like n minus 1 comma k, then n minus 1 comma k minus 1. It is showing like this, n minus 1, n minus 1 will be the constant, but k will be vary. So k, then k minus 1, then k minus 2, it is like that. So this one, then we have to finally do the mod. So mod, so let's create the mod into mod equals to 1e9 plus 7. This will be our mod. So finally what I will do is this one is the last. So dp we have to return the dp of n of k. So let's run this code and see if this will work or not. And here's the problem, it should be dp. So it is giving me wrong. So here should be a equal to sign for this. Now let's run this. As you can see, it is working perfect. Let's submit this code. It is working perfect. So this is the complete solution for this. So now let's discuss about time and space complexity for this. So as you can see, it is a bottom-up approach solution. If you use a memorizer, it will give you TLE, because we have to memorize we have to optimize the space also. So here the time and space complexity will be big of n into k. If you use a space optimization approach, it will be good for this. So this was a complete solution. If you find this helpful, then please like, share, and subscribe. And